Hello. Today I would like to demonstrate my revolutionary data structure, Slot Machine RDT. This data structure is so powerful that Oracle and Google should hire me and implement this as an official java.util. Before even getting to my data structure, I have to talk about every Vegas person's favorite thing, that being the slot machine. The slot machine is a machine that makes people lose money. The purpose of the machine is to give the user the dopamine rush of watching pattern toilet paper spin. Here is a detailed diagram of winning money. As you can see, the icons match each other, making this a jackpot. However, this is rare and unusual as you have to get the same icon in a row. Math explained later in this PowerPoint. This diagram is more accurate and likely. As you can see, the icons do not match each other, making this not a jackpot. I want to test how many rolls it will take to get a perfect 13 using 3 separate patterns. The purpose of this program is so I can make money. I mean to show the dangers of gambling and to make this data structure an official java.util. The tools that I will be using is my primary coding language, the Java Virtual Machine on VS Code. Here is my UML for my slot machine interface and class method. The slot machine holds 3 attributes, those being the number of jackpots obtained, the patterns in the slot machine toilet paper rolls, and the amount of toilet paper roll slots. The next step is to code my methods. Here are the general ideas of how my methods work. I will explain these methods later. As usual, we will be testing and debugging our program. Let's go to VS Code. Here is the interface, coded exactly the same as my UML. This is my implementation of the interface, with my constructors built and set with its corresponding attributes. Now I would like to go in depth to explain the more important methods. Next is the setSlotPattern method. To help the non-CS major viewers visualize my code, here is a diagram from my slides. Essentially, the setSlotPattern changes an old pattern toilet paper roll into a set new toilet paper roll. The next 2 methods are remove and add a slot pattern. Here's my diagram on how that works as well. As you can see, for my add a slot pattern, I simply add the Genshin Impact logo into my pattern toilet paper roll list thing, meaning now, Genshin will be a rollable object, changing the amount of patterns from 3 to 4. And the remove a slot pattern method is set to remove the lucky 7 icon from my pattern toilet paper roll, meaning it will not be a rollable option, changing the amount of patterns in the toilet paper roll from 3 to 2. Lastly, here is the code of my roll method. But for the non-CS people, here is a diagram explaining the roll function. I generate a random number from 0 to x, where x denotes the number of items in my linked list toilet paper roll. This newly rolled random number is my index. With a simple linked list method get, we can obtain our linked list object with our randomly rolled index. After we get the object from our linked list, we put that object in a slot of our array attribute. We iterate this process until we change all of the slots. With all the slots changed, we can get the roll we made. And here is my testing code. Under public static void main string args, I have created a new string array with 3 objects inside which I will initialize using. After initializing, we create a counter and a while loop. We keep on looping until we get a jackpot. While this loop is running, we will increment our counter, reroll using our roll function, and display the reroll. When the loop is finished, the program will print the amount of times we looped using our counter variable. For those who didn't get what I demonstrated, here is a diagram. I am testing the program using 3 different test cases. The first is a simple 5 pattern to 3 slot machine. The second is a 10 pattern 3 slot machine. And the third is the main event, the 3 pattern 13 slot machine. Theoretically speaking, I should expect the number of rolls to get a jackpot to be my number of patterns to the power of the number of slots minus 1. For case 1, my expected amount of rolls should be about 25 rolls. My second case should be about 100 rolls. and the main event should be about 531,441 rolls. Let's start with 3 trials of case 1. Next is 3 trials of case 2. Lastly, the main event for 3 trials. And just for fun, I'm gonna crash my computer with 5 patterns and 20 slots.